video has very scientific terminology. If you are looking for entertainment, this video is not for you.
أعوذ بالله من الشيطان الرجيم.
وهو الذي خلق الليل والنهار والشمس والقمر كل في فلك يسبحون.
بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. أحييكم في هذه الحلقة من قناة Space and Knowledge. Time travel stories are cool because both the past and future are somehow more interesting than the present, and because everyone secretly wants a do-over. But so far, it appears we are doomed to live consumed by regret in the eternal boring present. Time marches on unavoidably and only forward, or so we thought, until Einstein came along. His general and special theory of relativity changed the way we think about time forever. And believe it or not, the raw equations permit time travel. They even tell us how to do it. So let's review the possibilities and decide how possible time travel really is. The first approach to time travel uses only special relativity, which describes how time and space are stretched or contracted depending on relative speeds. A fast-moving spaceship appears to experience a slower rate of time compared to someone waiting back on Earth. Do a round trip around the entire galaxy at close to the speed of light, and very little time might pass from the perspective of the traveler, but they'll find a minimum of hundreds of thousands of years have passed. When they get back to Earth, however, that's a one-way trip in time and is really just traveling in the same temporal direction at different rates. But it'd be nicer to be able to go back in time. Actually, the math does sort of allow that. The spaceship's clock slows down as it speeds up, and it stops completely at the speed of light. And at faster speeds, time should actually tick backwards. So if you could travel faster than light, you could navigate a path to a point in space-time before you actually even departed. Of course, we know that the laws of physics forbid faster than light travel, or do they? In order for any object with regular mass to even reach light speed, it would need infinite energy, which can never be obtained. But notice I said regular mass. We can hack the equations of special relativity by allowing mass to take values in the weird realm of imaginary or complex numbers. An object with imaginary mass is now restricted to only traveling faster than light, never slower. That means it can only travel backwards in time, not forwards. We call a particle with imaginary mass a tachyon. If we could control tachyons, which are particles traveling faster than light, then perhaps at least we could send information back in time. But do they exist? Does imaginary mass exist? This is an example where the equations of a theory technically allow something to be true, but there's still no good reason to believe that it is. We've seen no evidence of tachyons, and common sense tells us that we probably never will. So special relativity isn't much help. Fortunately, we still have the general theory of relativity, which incorporates special relativity, but also explains the force of gravity as a result of curvature in the fabric of space-time due to the presence of mass and energy. But GR, which is general relativity, describes a warping of space and time. So maybe we can warp them enough to take us back to our own past. The best known approach is through something called a wormhole, which I've explained in my previous videos. A wormhole is a remarkably bizarre consequence of general relativity. Now, if space can be warped, then perhaps it can be stretched in such a way as to create a tunnel between 2 points, and one whose internal distances could be very short, even if the mouths of the tunnel are far apart. This has the obvious benefit of allowing you to teleport between distant points in space, but also between distant points in time. This is how you do it. Take one stable wormhole large enough to cut through, accelerate one end to close to the speed of light, or drop it into a deep gravity well. Its rate of time flow will slow relatively to the other end of the hole. Now bring the two ends back together. They will be offset in time. One portal, permanently stuck in the past of the other by some sort of interval, travel through the future end and you'll exist in the past. So this sounds all straightforward enough, but can wormholes even exist? There are a number of ways they might, from connections between universes in the interiors of black holes to tiny wormholes appearing and vanishing on the tiniest scales of space and time. And also, to build a useful time machine, a wormhole has to be large enough to fit through, and it has to be stable. The equations of GR, general relativity, do permit large wormholes, but they are definitely not stable. They collapses on themselves instantly, leaving obvious black holes. In order to keep our wormhole time machine operational, its throat needs to be kept open. We need to counter gravity, and to do that, we need a probably non-existent form of mass, negative mass, also referred to as exotic matter. As far as we know, mass can only take on positive, real values, so a requirement of negative mass seems a non-starter. However, there may be hope, and I say may. Really what we need to do to open the wormhole is a negative energy density, which some scientists call it dilithium crystals. However, there is no clear path to translating this to a large-scale negative energy distribution that could keep a wormhole open. And in fact, we'd need entire planets, perhaps entire stars, converted to negative energy. To do this, some other time travel options also involve using negative energy densities. In short, if you have exotic matter, you can probably travel back in time. But is negative mass energy as much of a non-starter as imaginary mass? While the actual equations of general relativity themselves don't prohibit it, there are a set of secondary rules in GR. They're a set of requirements that do things like prevent negative energies and enforce energy conservation. But the energy conditions don't have a really fundamental basis, and they're seen to be violated in some cases. We can't completely rule out wormhole or warp drive time machines based just on the energy conditions. And as it turns out, there may be other ways to build time machines without either negative or imaginary masses. One example is the Tipler-Tindler, conceived by Frank Tipler, based on a solution to the Einstein equations by William Van Stockham. It's simple. Just build an infinitely long cylinder of extreme density and set it rotating insanely quick about its main axis. It will drag space-time in its vicinity into some sort of vortex. This generates sub-light speed paths through the space-time that form closed loops, ending up back where they started in the space and time. We call such paths closed time-like curves. A spaceship traveling along one of these curves could return to a point in its own past. If you do not have the budget for an infinitely long cylinder, you could try building a very, very, very long cylinder and be horribly disappointed. Stephen Hawking showed that unless the cylinder is infinitely long, this cannot work, unless you also modify the space-time with negative energy. So it turns out it's not so hard to find solutions in general relativity with closed time-like curves. All you need is a wormhole, negative energy to time travel back in time. In the end, I would like to say that these are still theories that scientists have still not proven. كل هذا والله أعلم. And see you in the next episode where we talk about the mysteries of aliens and do they actually exist. See you. Wassalamu alaikum wa rahmatullahi wa barakatuh.